Welcome to another deep dive. Today, we are exploring this document called Dryer Vents, Inspect What You Expect.
It's a really fascinating document, honestly, because we usually treat a dryer vent as this simple binary problem, right? Like,
Yeah.
it's just a dirty tube that needs a quick scrub with a brush.
Yeah, that's definitely how I always pictured it. Just, get a brush in there and you're good.
But when you actually examine the professional standards for evaluating these setups, specifically the comprehensive inspection procedures designed to diagnose these issues, we aren't dealing with a static tube. We are looking at a dynamic, interconnected, air-moving system.
Which completely changes the standard for what a proper service call should actually look like. And I find this fascinating because, my instinct would absolutely be to pull the machine out to see what's going on back there. I'd be like, let's look at the hose.
It is an incredibly tempting instinct, even for experienced technicians.
Yeah.
You want to see the problem, but doing that can instantly erase the very problem you were brought in to solve.
Wow.
Yeah. So the absolute golden rule of starting an inspection is to leave the closed dryer exactly in its existing operating condition. The diagnostic process begins with just observing the system untouched.
So let's unpack the logic there because it really highlights the difference between just blindly cleaning something and actually diagnosing a failure.
Right.
Because if I yank that machine forward, I'm guessing I run the risk of altering the evidence, so to speak.
You're altering the scene. The transition duct, that's the piece connecting the back of your dryer to the wall, it's flexible.
Right, the foil-looking thing.
So if that hose is severely crushed against the wall, pulling the machine forward might accidentally unkink it.
Oh, I see.
Yeah, you just fixed the symptom temporarily, hid the root cause, and completely ruined your ability to gather accurate baseline data.
That makes total sense. You have to record the environment exactly as you found it.
Exactly. And plus, prematurely dragging a heavy machine can actually tear an older transition duct.
Oh, true.
So if a technician causes that damage by just yanking it out, they suddenly own a problem the homeowner hadn't even agreed to repair yet.
Yikes. Yeah, so the hands-off approach protects the data, and it protects the technician, which leads to the actual first step, right? Looking at the outside of the machine.
Right.
The procedure starts with visually inspecting the dryer for pre-existing scratches, dents, or damage. Just documenting what is already there before anyone touches a single tool.
There is a very practical field service maxim that drives this step, and it's last in, first blamed. Establishing the physical condition of the appliance protects everyone involved, but the hands-off phase doesn't stop at just a visual check.
Right, there's more.
Yeah, the next step is to actually turn the dryer on while it is still sitting undisturbed and simply listen to it.
See, I wouldn't have thought of that. What exactly are we listening for?
Unusual mechanical friction. So
Oh.
things like scraping or maybe a rhythmic thumping sound,
Okay.
because those sounds point to a failing drive belt or a worn drum roller or a bad motor bearing.
Oh, I see.
Right? Those are appliance problems, not exhaust system problems. If the technician doesn't separate mechanical appliance failures from airflow restrictions early on, the whole diagnosis gets really muddy.
Which brings up the heat check, too, because you have to verify that the dryer is actually producing heat.
Yes, absolutely crucial.
Because, as a homeowner, my only symptom might be, my clothes are damp after an hour, so I just assume my vent is clogged.
That's true.
But the vent could be pristine, and my heating element might just be dead.
Or a burner malfunction in a gas dryer. Right. Verifying heat proves the machine is actually doing its part of the job.
Okay, so we've looked at the exterior, we've listened for mechanical scraping, we've confirmed the heat works. Now we can finally open something up, right? The lint screen.
Yes. But there's a huge caveat here.
Right. You remove the screen, you shine a flashlight down into the filter cavity to look for heavy accumulation, but you absolutely do not clean it out yet.
Scooping out a handful of lint from that filter housing actually alters the airflow. We haven't taken our baseline performance measurements yet. If you change the conditions now, you invalidate all the upcoming tests. So you just look and you wait.
Got it. And that same restraint applies to checking behind the machine, right?
Yes. Whenever possible, you inspect that transition duct without moving the appliance.
How do you even do that? It's so tight back there.
Use a flashlight, you peer over the top, or a great trick is to slip your phone camera back there with the flash on, just to see what you're dealing with.
Oh, that's smart. So we are looking for those kinks and compressions we talked about earlier, but we are also looking at the materials themselves, right? Because the source mentions that flexible plastic ducting, and that super thin, flexible metal foil-type ducting are simply not acceptable materials.
Yeah, they just fail to meet the necessary safety and performance standards. Code-compliant materials are strictly required here.
Because they can't handle the heat?
Well, heat, yes, but also they need to be listed and labeled specifically for closed dryer use. You want a material that maintains its shape, resists punctures, and doesn't create internal drag on the air.
Makes sense.
You are also looking for any evidence of disconnections or leakage back there.
Like a fine dusting of lint coating the wall behind the machine.
Exactly. If you see that, it means the exhaust air is escaping before it ever even reaches the wall duct.
And that escaped air is warm and loaded with moisture, so it isn't just a messy housekeeping issue. It is actively dumping humidity into your laundry room.
And even worse, some of that loose escaped lint can actually get sucked back into the appliance's intake.
Oh, wait.
Yeah. And then it starts accumulating internally near the heat-producing components, which is a whole other problem.
Wow. Okay, which is the perfect bridge to the next major phase of the inspection. We know the state of the machine and the connection. Now we need hard data. It is time for the before reading.
Yes. To get this, we finally clean the lint screen, replace it, and then set the dryer to a very specific setting, which is air only to no heat.
Let's talk about the physics there for a second, because that feels important. Why no heat for the test?
Because heat changes the physical properties of the air. Hot air expands, right?
Right.
And that expansion creates different pressure dynamics than room temperature air. By using the air-only setting, we remove temperature fluctuations entirely from the equation.
Oh, I see.
Yeah,
And there isn't just one single industry-mandated way to take this measurement, right? There are multiple legitimate methods that technicians use.
that is a vital distinction. There's no one perfect way. Some professionals measure airflow velocity at the exterior termination. So the vent on the outside of the house using an anemometer to see how fast the air is exiting.
Okay.
Others measure back pressure near the back of the dryer, which
Right.
basically calculates how much resistance the air is fighting against. And some even measure negative pressure from within the dryer drum itself, which determines how hard the blower motor is working to pull air in.
So no single method is the only right one. The goal is simply to establish a mathematical baseline.
Exactly.
And I really appreciate this underlying principle from the source. It says, measurement tells us how the system is performing. Inspection helps determine why.
A pressure gauge can tell a technician that the blower motor is fighting a massive restriction,
Right.
but a pressure gauge cannot tell you if that restriction is caused by a crushed hose, a bird's nest, or a broken booster fan.
The numbers just tell you a problem exists.
Exactly.
The procedure dictates that the inside of the closed dryer itself needs to be evaluated for lint accumulation.
Yes.
I always assumed the vent system started at the wall. Opening up the appliance sounds like a repair job, not an inspection.
A lot of people think that. But we really have to redefine where the exhaust system begins. It begins at the blower motor inside the machine.
Okay, so we're going inside.
We are. But before doing anything, the technician must disconnect the dryer from electrical power. Safety first. Always.
Absolutely. Unplug it.
Once the machine is unplugged, they open the cabinet to inspect the internal components.
Because lint doesn't just neatly bypass the machine and collect in the pipe.
It accumulates around the heating element in an electric dryer or the burner assembly in a gas dryer.
Wow.
Yeah, internal dryer inspection is an integral part of evaluating the complete system. Now, I will say, accessing these areas varies wildly depending on the manufacturer.
I imagine.
Some models have an easily removable front panel. Others require significant disassembly. So the technician has to follow the specific manufacturer guidelines for that model.
But the crucial takeaway for you is that this step cannot be skipped. If a company comes in but completely ignores a dense blanket of lint inside the dryer, they haven't actually evaluated your system.
They've only done half the job, honestly.
So we have our starting metrics. This brings us to the permanent exhaust duct hidden in the basements, crawl spaces, attics, or, ceiling joists.
Here we are looking at the routing, the developed length of the run, the elbows and turns, and the integrity of the joints and seams.
Let's talk about those elbows and turns, because a perfectly clean, lint-free pipe can still fail a performance test if the physical layout is just terrible.
Well, absolutely.
Like, think about blowing air through a standard drinking straw. If the straw is straight, it's effortless. But if you take that same straw and bend it sharply at a 90-degree angle in 3 different places, you have to blow significantly harder to push the same amount of air through.
That is a perfect analogy. The fluid dynamics of air traveling through a tube dictate that every single turn creates friction and turbulence.
Right.
A short, straight run through an exterior wall offers almost no resistance. But a duct, navigating around plumbing pipes and floor joists with multiple elbows, that creates immense back pressure.
The inspection requires looking for disconnections or damage, right? Because a separated duct in a dark, unconditioned crawl space is just a silent disaster.
A silent, very wet disaster. A disconnected duct isn't just failing to vent the dryer. It is actively pumping gallons of warm, moist air directly into your home's structural cavities every single time you do laundry. That moisture can warp wood, degrade insulation, and contribute to severe unseen issues behind your drywall. The goal of the exhaust system is to carry the air completely to the outdoors. The inspection verifies if it's actually making it there.
A clean duct is worthless if it's disconnected, crushed, or made of the wrong material, or if it's being blocked by a failed mechanical component, like a booster fan.
If a booster fan loses power, it stops being a helpful fan and instantly becomes a physical roadblock, plugging the duct. It must be identified and evaluated during the inspection.
So we follow the air through the walls all the way to the finish line, the exterior termination. And the inspection does not stop just because the pipe has breached the exterior wall or the roof.
No, in many cases, the exterior termination is where the most severe restrictions occur. We have to check the damper. Does it open fully when the air is blowing and close securely when the dryer is off? Or is it wedged open by a chunk of lint?
Or has a well-meaning house painter accidentally painted the damper shut, sealing the vent completely?
We also inspect for landscaping that has overgrown and blocked a wall vent.
And we have to talk about screens, because the procedure specifically requires checking for improper screens.
A dryer termination must allow unobstructed airflow.
Vent materials matter. The entire system must use code-compliant materials, adhering to applicable building codes and the dryer manufacturer's specific venting requirement. Okay, so we have tracked the air from the machine to the outdoors. That brings us to the after reading.
Yes, the proof.
And this is where we have to highlight a stark distinction between two concepts that get thrown around interchangeably: cleaning and inspection.
They're completely different scopes of work. Cleaning is the physical act of removing accumulated material from the system. Inspection is the comprehensive evaluation of the condition of the complete system. A technician can clean a duct without ever realizing the roof damper is broken. They can remove lint while leaving a crushed transition hose behind the machine.
Or leave a ton of lint inside the dryer.
Exactly. Cleaning without inspection is just blind maintenance. True professional service is driven by what the entire system needs to function safely and efficiently.
And to prove that the service actually addressed those needs, the procedure requires an after reading.
You must repeat the exact same performance measurement you took at the beginning.
Recreating the exact testing condition.
Yes. The before reading establishes your baseline. The after reading proves the efficacy of your work.
Got it.
If the airflow velocity increased significantly, your measurement verifies the problem was solved. If the numbers didn't improve, the technician knows immediately that a hidden restriction still exists and further investigation is required before they leave.
But the job still isn't technically over, because if the dryer was moved away from the wall to perform the service, you have to reposition it.
You have to verify that the transition duct remains securely connected during the move. You must confirm that the hose wasn't accidentally crushed, kinked, or torn while the machine was being pushed backward into place. And then there's the absolute final step of the entire procedure, returning the dryer from the air-only test setting back to its original heat setting. Operating it briefly to confirm that it is in fact producing heat. The technician arrived to an operating dryer. They must ensure they were leaving the homeowner with a fully operational heating dryer.
It is a meticulously logical sequence.
Very methodical.
It moves from observation to baseline data to internal components, and finally back to data verification. It embodies a philosophy of measure, inspect, diagnose, service, measure again.
It replaces guesswork with empirical data. And honestly, it should be the standard expectation for any homeowner.
Absolutely.
If someone is evaluating your exhaust system, they need to be looking at the appliance, the transition materials, the permanent duct routing, and the exterior termination. Well, thank you all for joining us on this deep dive.
We'll catch you next time.